Please.
Okay.
Yes, Dr. Wang, it's your floor now.
Okay. Thank you, Dr. Aveni and Dr. Ibrahimi. It's my pleasure to have the opportunity to participate in this workshop. And I also pleased to share the ground station networks and the engineering experience to share with all the participants. So before I give this lecture, I also would like to introduce our Beihang University. Okay. Okay. Can you see it? Share the screen. Is it okay?
Okay.
Okay. Yeah, I come from Beihang University and also regional center of for space science and technology education in Asia and the Pacific in China. This Beijing, and our campus include two campuses. One is the main campus located in Xueyelu Road, and another campus we call the Shaga campus, 27 kilometers away from the main campus. And this the different the campus. And the first, the main campus is founded, is established in 1952, and the Shanghai campus is in 2014. Our university was established in 1952 through a merge of the aeronautics departments of 8 top Chinese universities, including Tsinghua University, Tianjin University, Xiamen University, Sichuan University, and so on. And until now, it is the first university in China focusing on aeronautical and astronautical education and research, and it is also listed in top 20 universities in China, and also list top 5 engineering universities in China. They are in at present in our university we have 189 academic programs, include undergraduate programs, master degree programs, and doctoral degree programs. And the student enrollment is more than 30,000, and graduate student is more than 15,000, and the postgraduate students include the master degree, and the doctor degree is 14,000, more than 14,000. And additional, we also have the international students around 2,000. So our university is an open university in China. During the past decades, there are over 200,000 alumni around in China and also in worldwide. There are 39 schools in our university. It includes engineering schools, science schools, economy and management schools, and also the multi-culture schools. There are 10 main disciplines already ranked top 10 nationwide. Include we can see aeronautics and astronautics, instrument science and technology, mechanics, control science and engineering, computer science and technology, software science engineering, biomedical engineering, management science and engineering, transportation engineering, material science and engineering, power engineering and engineering, thermophysics, mechanical engineering, and information and communication engineering. There are 9 national key labs in our university, and also 5 national engineering research centers in our university. And our university has strong presence in China aerospace industry. Our students, when they graduate, most of them participate the industry department, such as the airplane design and manufacture, and also the satellite and the launcher design and manufacture, and so on. Such as in 2016, we launched the China's most powerful carrier rocket, Changzheng 5. At present, we also have fast-growing publications in fundamental research. For international educations, we already have a series of international students and programs. There are more than 2,000 international students from 106 countries. The international programs include the undergraduate students program, master's degree program, and also doctor degree programs. And we have 2 international education and training center. One is the Regional Center for Space Science and Technology Education, and another is APSCO Education and Training Center in China. So we can have a look at the international programs, education programs. Normally, for the international educations, for the bachelor, it will last 4 years. For master degree education programs, it will last 2 or 3 years. And for doctor degree programs, it will last 3 or 4 years. And we at the same time, we also hold a series short-term training in summer or in winter, and the training time is different. In our university, we also supply a full-time and a full scholarship program for international students. It covers tuition fee, accommodation, living allowance, normal medical service, comprehensive insurance, but it will it not cover the international travel expense. The students will study period is 2 or 3 years for master's degree and 3 to 4 years for doctorate degree program. And the students in university, the working language is English, and also they will also learn the Chinese language and the Chinese culture. This is the professional, some of our professional labs, and this is the living the conditions, and this the living facilities. So it is very convenient in Beihang University, and since our university is an open university, we welcome the international students to participate Beihang University and study. Okay, then after the a short introduction about our university, I will give our the lecture. My topic is okay. My topic is multifunctional ground station network and space education. My lecture I will introduce the ground station network established the background, and I also will overview the global ground station network, and then I will more focus on our regional center ground station system, and we also developed the ground station network system management software. I will introduce about our works. Then, based on this ground station the facilities, how we have pushed forward international space education and training in Beihang University. Firstly, I will introduce about ground station. Background is APSCO small student satellite project. This project is kicked off in
new slide. Do you share your new slide?
What?
We didn't see your new slide.
Oh, okay. Wait a moment. Oh, okay.
Okay.
Can you see?
Yeah.
Okay. Okay. Good. My topic is multifunctional ground station network and space education, and I will more after I introduce our ground station network background and overview the global ground station network. Then I will more focus on our regional center ground station system and also the ground station network management software we designed by ourselves, and also based on these facilities, how we push forward the space education and training. The APSCO small student satellite project, in short, we call the APSCO project. It was kicked off in December 2016. It is the largest basic activities of APSCO. And our Chinese National Space administrations will provide the launching service in China. All the APSCO member states include Bangladesh, China, Mongolia, Iran, Pakistan, Peru, Thailand, and Turkey. All the member states participated in this project. And Beihang University was identified as the leading university. This project aims to train students and faculties from member states for satellite engineering through hand-on practical training until the satellite flight model is made and in orbit. Then the objective to develop their own space education system, build their own capacity to develop small satellites, and build their own payload and subsystem integrated on the satellites, build their own capacity to operate satellites and process image and payload data. This project includes 3 satellites. One is microsatellite. It is 30 kilograms. We call it SSS-1, and 2-3 units. We call the SS-2A and SS-2B. They are the CubeSats, and they will launch together by the launcher in China. And the payloads include the remote sensing camera, radiation monitor, AIS and ADS-B receiver, GNSS receiver, a space deployed mechanism, and inter-satellite communication payload. So these the 3 satellites. For SSS-1, the technical configuration include the platform and the payload. The platform includes the main subset, the carbon mast, the GAS solar array, and the lead-ion battery pack. The ARM processor with CANvas and passive and active attitude control, and passive and active thermal control, S-band and UHF and VHF transceivers. The payload includes the inter-satellite transceiver, remote sensing camera, ADS-B receiver, and radiation dosimeter. And SS-2A, the technical configuration is 3 unit. It is a 3-unit CubeSat, and it also assembled the optic, the camera, and it also has the mammoth propulsion. It uses the gamma link work as the interlink communication. And SS2B also is a 3-unit cube size. But it is designed by Turkey side. So from this, the project, the 3 satellites will launch in SSO orbit. The orbit altitude is 500 kilometers. The in-orbit lifetime is more than 6 months. And the S-band uplink, we use the S-band uplink and the S-band, the downlink, the frequency, and the VHF frequency as uplink, and the UHF down work as downlink. The TT&C, UHF, and VHF, we select AS.25 protocol. This feature. So from this project, we can find there are 3 operational segments in this project. One we call the space segment. They are include 3 satellites, small satellites, and the ground station. It is the key facilities of the ground segments. And another we call the user segment. That is the terminal, the user terminal to use the satellites, the days. So from this segment, we can find the ground segment, the ground station. It is very important to track and uplink the telecommand and receive the telemetry data package. But if only one ground station,
We miss your voice, Dr. Wang. Dr. Wang? Dr. Wang, do you hear us? We are sorry for the disruption of sounds from the source, from Dr. Wang.
Yes, please, Dr. Wang. We are not hearing you. أخ إبراهيم، شو في إشكال شيء؟
شكرا دكتور، فصل من عنده من النت.
I think so.
he gets back. Dr. Wang, can you re-enter the room again? You don't hear anything from your side. We are sorry for the inconvenience. Please wait until Mr. Wang reconnects to the net again. He's getting back. Mr. Wang?
I will send him a message now to see what's the problem.
I see that he's getting back. Dr. Wang, do you hear us? Dr. Wang?
I think it is better someone to contact Professor Wang again.
Yes, I have already just sent a message to him and to other colleagues, and they are trying now to, you see, reconnect. Let's hope that we will, within 2-3 minutes, maybe we'll get it.
Thank you.
Mr. Wang, please leave the meeting and then get in back again. Then the problem will be fixed. Please leave the room and then get back again, please.
Now he's trying to join again. ابراهيم صوته كيف عندك ميوتد ولا لا؟
لا هو اصلا هلا خرج بس كان مش ميوتد، معمول كو هوست اصلا هو.
اتاكد بالله اذا سمحت.
Okay. Yes, Mr. Wang.
He's still trying. Just he has sent me a message.
Yeah, he's now on. Please, Dr. Wang.
Hello.
Hello.
Yes. You
Can
are.
you hear me?
Yeah.
Yes, we are hearing you.
Okay, good. There is something wrong. So I will continue my lecture.
Yes, please.
Okay.
Yes, Mr. Wang, please.
Yes. Okay. So based on our Beihang University ground station, we do the coverage analysis. We found the communication since it is the LEO orbit. So the satellite and the ground station, the communication time is very limited. On average, it is around 8 minutes per orbit. So once the satellite is outside the communication coverage, the date and the satellite status, we do not any information. So it is a very key problem. Since one ground station, the capacity is very limited. If we establish many ground stations and the ground station establish a network, then it will improve the communication, the time. So this is our original ideas. Based on our ideas, we already surveyed the global ground station network already established. One is we call the Planet Labs ground station network. It is we know the Planet Labs is a commercial space company. It already launched 133 satellites, and at present they are 36 satellites in orbit, and it supplied the remote sensing images to the customers. And the ground station, ground segment, they already established the 5 meters diagram dish antenna, and the up to telecommand is 100 watts for S-band uplink, and it also has the integrated UHF feed on the dish. And here is the Planet Labs ground station network distribute, and also the globe. But since it is a commercial company, for the data, it is not open and can be transferred to the students for education and training. So this is the shortcoming. Another way we surveyed the AWS ground station network. It also an international ground station network. And this is the AWS ground station cloud computing. That means they announced for the customers, they can only supply the request for them. Then all the service they can supply it for the customers. This is the architecture of their ground station network architectures. And for the AWS ground station, it also has the same. The shortcoming is it is not open for the users, and it is not suitable for the students or young engineers for to space education and training. And another we call the GNSO ground station network. It is established also in the universities, distribute in the worldwide, and the project team established the ground station network software to management the different ground station nodes. It can give the some education and training the functions for the users. So we more take the GNSO ground station network as a reference to establish our GSN. They designed the booking request and leave web in the website for the users. And another is the ESA ground station network. It is more focused on the ESA, the member states. The ground station distribute the Europe and South America and the other the place, and it is more focused on the national and the large the space project in Europe, and this is their ESA ground station network. From this architecture, we can find the ground station network can be divided to 3 layers. The first layer we call the customers. The customers can supply the different requests to the second the layers we call the central ground station mission and control center. Then the mission control center will distribute the request to the different the ground station in different place and to track and receive the satellite the data package. This their network. This figure showed our Chinese National Space Administration ground station network. The central, it also divided 3 layers. The first layer is the different users, and the kernel layer is the mission control center. The mission control center located in Beijing and Xi'an. The Beijing Mission Center is more focused on the mission requirement, and the Xi'an Control Center is more focused on the engineering scheduling. Then the Xi'an Control Center will distribute the different the schedule to the different ground station in China, such as Kashi, Jiangsu, and Sanya, in different places. But still now, the CNSA, the ground station network, already supplied the service for the deep space exploration, lunar exploration, geosatellite, and Mars exploration, and so on. So, how we can establish our regional center ground station systems? Our objective is to provide UHF, VHF, S-band, and X-band ground station service. And we established mission control center to complete the in-orbit satellite prediction, monitoring, displaying, and control service, receive satellite payload data, and manage the satellite data sharing. The network has the remote control, monitoring, and automobiles operation functions on schedule. That means not the operators not always on duty day and night, so we can use the teleoperation to operate the GSM, and it designed the interface to our regional center network and data sharing. And we also provide international space engineering practice, education, and training for students. On one side is Chinese students, and we also opened and supplied the training practice for international students. Since it covered a lot of we already has the capacity, so we provide the aerospace special technical support for and service for aerial satellites. At present, we already have a close relationship with the different satellite companies, and we can supply the professional, the technical service for them. And the ground station network expected outreach is international ground station network in our regional center, and we can supply the professional space education and space engineering training platform. And it is an important international academic exchange platform. Some key basic space capacity in regional center for space AI, things of Internet of Things, smart city, smart agriculture, blockchain, remote sensing, public service, and so on. It is an outstanding space STEAM education landmark for young generation, especially for high school students. This is our ground station UHF and VHF technical specification. And this our S-band and S-band and X-band ground station structure. And this technical specification for S-band and X-band ground station in Beihang. And the ground station, our ground station has a remote operation and automobiles operation. That means for the operators, they do not every day on duty in the operation room. So we can programming and operate the ground station facilities on schedule. This is some of our ground station facilities distributed in different ground stations. On the top is the antenna located in Beihang campus, and on the bottom, the left is located in Sanya, and the right located in Ningbo. Then our team members can operate the facilities and track the satellite in orbit, and also received and decoded the telemetry, the data package of the satellite. The signals we received from the satellite in orbit. These are the ground station facilities, hardware and software. So why we establish the ground station network? Just a moment, I already introduced. For one ground station, the communication time is very limited, and for one ground station, it has a low efficient to track the satellite, because for some universities, there's not always have the satellite to track. And maybe for some universities, they are limited the financial budget to establish the ground station. So if we establish the ground station, we can improve the communication time and improve the ground station the efficient, and also can supply the service for more users. And we also can avoid the sort of the finance. That means if for some universities, if they do not have the enough the financial support to establish the ground station, but if the university participate our ground station network, then we can share our the satellite and the data package and the date to them. So then we can use get more application for the satellite days. At present, we draw a layout of the ground station nodes distributed in the globe. It includes the Asia, South America, Africa, and Europe. In the ground station network, it is the central center. It is we call the mission control center, and the data process arch center. This is the ground station central kernel central. The functions, the mission control center, the functions is scheduling the ground station resources allocation, management plane, receiving satellite telemetry data and the payload data to generate the satellite telecommand and uplink to satellite. And it also has the orbit control for spacecraft.
أيوة.
It has the different satellite display, and it also can supply the international space technology engineering practice, education, and training. So this since our ground station is open and for education and the training practice, so it is open and it has the education function. This is our the mission control center's display, functional display, and it can monitor the different ground station nodes and can do the orbit prediction and also can receive the data package and also can display the telecommand to uplink. This the mission control center technical configuration. It includes the technical support module, resources sharing service module, satellite control module, station network management module, and operation management module. And they are the other two modules we call the education and the training module and the teleconference module. Based on this platform, we can give young students and young engineers the professional education and training for them. Here I give an example. We track the satellite launched in China. It is called Fengmaniu 1, launched on February 4, 2018. The launcher launched in Jiuquan satellite launch center in China. Okay, after the satellite separated from the launcher, our ground station has tracked has to track the satellite. When the satellite passes over our ground station, our ground station tracks the satellite and successfully receives the signal beacons, the beacon signals. Here, this is displaying the beacon signals. After that, we use our software to decode the beacon signals. After our decoded the beacon, it is verified that this beacon signals is our Fengma 1 transmit. So that means our ground station received the satellite signals successfully. Okay, then we continue. Use our ground station facilities. We continue track and receive the ground, the satellite, the payload, the data package. The Fengma 1 assembled a CMOS camera. So we received the CMOS cameras, the data package, and decoded successfully. So this the camera image in orbit. And this is the original code, original date we have decoded. And this is the ground station, the network system. We have designed and developed the ground station network management software by ourselves. This management software divided two sections. One is we call the system management. That means it manages different ground station system management and user management. And another section we call the data management. That means it includes data sharing, exchange, data displaying, telecommand transmitting, and telemetry data receiving. According to the different the satellite data protocol, we can design the detail the functions. Here, this is the interface of the system management, and this is the monitoring and the recording interface, and this is the data management interface. And this is the telemetry data package decoded interface. At present, this we design and write in Chinese words, but it is no problem for us. We also will develop the English version software. For the data display, we also use the Cesium software platform to design the satellite orbit prediction the functions. So it is very similar like the SDK the software. But our software it is open. It is open for students and for young engineers for space engineering practice and training. In our regional center, we give the professional space education and training for young students and young engineers. We supplied the different level education and training. The first level we call the professional level. It is more focused on the high degree students, such as master degree, doctor degree, and young engineers. We hold the different short-term trainings for them. It includes the conference, the summer or winter school, and the workshop and the seminar for them. In our regional center, the students studied in our university, and they studied for master degree or doctor degree. So the study period is long. We call it long-term education and training. And the students, when they can finish their the course study and the thesis research works. During their study, they also participate the different international small satellite design contest and do the academic research and activities. And we give the students the TP design project every year. We give them, and the students, when they do the works, they also can publish the academic paper. Another level we call the low level. It is the primary level. It is more focused on the space STEM education. It more focused on the high school students. It is during the past years we already hold the different programs for them. It is more focused on. It is more held in the summer holidays and the winter holidays. We call the summer school or the winter school. And during the short-term training, we give the different the topic for the young generations. But it is still more focus on the hands-on practice for them. And we also hold the CanSat in China. It's similar as the competitions in ESA and NASA. In 2018, we already developed the CanSat the facilities. It includes the CanSat the rocket and the different CANSET components. Then we can supply the components and for the young students, and then they can use our the tools and the facilities to design their innovation products. This is in last year we hold the summer camp summer camp in Beihang University for CANSET contest, CANSET design contest, and the different the high school students participate in this and finish their products. This is the final contest. It held in Qingdao. Here I give a video. Okay, so by this way, we the different the teams, their works can be tested and verified. Then they get the contest results. Then the professors committee will evaluate their work performance, and then give the different the certificate for them. Since the United Nations already established 6 regional centers, so we suggest we establish the regional center alliance. Then we can share our work experience and share the academic exchange and supply more resources for students in different regional centers. Yeah, this the 6 regional centers. Lastly, I give a brief summary that our regional center ground station already established in Beihang University. It is use the modular design and has the standard interface, so it is easy to improve the ground station network capacity in the future. And in our side, we also welcome the colleagues participate our ground station network, and then we can share the resources and share the satellite days for young students. That's all. Thank you.
Thank you, Dr. Wang. Please, we have Dr. Ammar Sakaji wants to ask a question. Please, Dr. Ammar.
Yeah. Hello. Thank you, Dr. Wang, for the nice presentation. Thank you so much again for involving Jordan in STEAM education, your network. Thank you. Actually, my question, you mentioned that we'll share resources for the STEAM education, but I don't know, the STEM education in China or China campus will be in English or in Chinese. I'm not sure, because I think we have to cut the barrier language communications, because it seems to me it's in Chinese. The STEM education in China, in which language, and how to share resources.
Okay. In our regional centers, it is our regional center is international. We supply the international space education and training. So the working language is English language. So for the documents and the lectures on the discussion and the data sharing is all in English version.
Thank you. One more question about the STEM terminology. As we know, STEM in the United States terminology means science, technology, engineering, and math. And you mentioned a new phrase, space STEM education. What do you mean by space STEM education?
Okay. You mean the space STEM education, yeah?
Yeah.
Okay. The space STEM education means S means science. S means science. T means technology. E means engineering. M means mathematics. So that means for the it is more focused on the high school students, for them to supply the hand-on practice for on space technology.
Dr. Ala Al-Nahri, please.
First of all, thank you very much for the high quality presentation of Dr. Wang. And I like to catch the opportunity to appreciate the great efforts of Professor Dr. Auni Al-Khassauna to contact with high expertise all over the world. My question is, I noticed that the western area of Asia is not covered by receiving station. What are your plans to establish a new one in that region? And I want to cooperate as a regional center of West Asia with you for more scholarships between the two countries. Thank you.
Okay, thank you. If you would like establish a new ground station, and they are include I think they are include two works. One is the system design, and another is the facilities, include the hardware facilities and also the software, and also do the system integration. In Beihang side, we already established the ground station network. So we have the engineering experience. So if you have the request, we would like to support you to establish the new ground station. And we also can, according to our experience, to give your suggestions, such as the functions, and the technical specifications, and also if the ground station applications and space educations for the operators and the users. We can supply. We would like.
Yeah. Thank you very much.
Thank you.
Okay.
I don't see any more questions. There's any more questions? Please raise your hands. Faris Bani Fres, please.
Hello, everybody. Thank you. I would like to first of all thank everyone who has contributed to this very interesting meeting. It is a meeting that we can all, we share information and we learn every day. We gain new knowledge. I would like to thank Mr. Auni Khassaouni for his efforts in this case. And I would also like to thank Dr. Wang Xincheng on his very clear elaborations on this very important topic, which is talking about ground stations. However, I do have a question for Mr. Wang, and I would be very glad if we can have clarification on the point. Now, on this point, now we know that ground station operations is, there are different ground stations in different countries around the world. And maybe each ground station is related to a certain space agency. So do you think, Dr. Wang, that the distribution of ground stations around the world in each country is fragmented in some way or another? And do you think that we should have a comprehensive treaty that actually sets out the activities and outlines the objectives clearly and specifically of those ground stations? Or do you think that the current legal regime surrounding ground stations and talking about ground stations is extensive enough for, agencies to conduct space operations and to, basically do their work in regards to ground station work? Thank you.
Okay, yeah, I understand. The ground station distributed in the globe, it belongs to different countries or different space agency. Yeah. For our ground station network, we would like establish the global, the public, the data sharing, the ground station network. So if the ground station wish to participate the ground station network, it need get the approval of the space agency. That means their data can be sharing with other ground stations and the operators. That will be okay. We already consider this. Maybe some ground station, the information and the satellite, it is not can be public. We also understand this. We understand this. So in the ground station, the management software, we already consider this condition. So according to the participants, the requirement or request, then we can give the different limitations, different level limitations. that means for a specific ground station, they have their rights to do. We understand this. In our ground station network software, we already consider this condition. So for this, if the technical works, we need a discussion.
I just have to ask everybody who wants to ask a question to introduce himself before asking. Mr. Oshi, please.
Hello. Oh, this is Osama Shalabiya from Egypt, the Dean of the Navigation, Science and Space Technology at Bani Suef University and the Director of the Space Science Center at Cairo University as well. So let me first thank you, Professor Wang. Thank you very much for your elegant and interesting talk. From the point of the education and space education, which the title attracts me to attend and to keep an eye on your talk, we would like to, for the plan of the building capacities, as you may know that Egypt has now this Egyptian Space Agency, and we also are going to host the African Space Agency as well, the headquarters, I mean. So we are more focusing on the building capacities for our human research in this direction. So our students look for dual degree or joint degree with your university in the space education or space technology and navigation science as well. So this is one point of my questions. The second is, how can we put an MOU, like a memorandum of understanding, or exchanging for the visiting of our students in training programs, both in undergrad and postgraduate students? Thank you. And thanks for Dr. Auni for this golden chance that we can have one of the most professionals professor in the field that we are seeking and looking for the collaboration with them. Thank you again.
Okay, thank you. Yeah, I understand. I understand your situations. For our Beihang side, our university is open university, so we welcome the international students participate and study in Beihang. So if in your country, or in your university, if the students would like studied in Beihang and participate in our regional center. Our regional center to study space technology. We welcome. So I wish we can. I can give my contact address. Then we can keep in touch and discuss this. And for MOU.
Thank you. That's I'm looking for, please. Yes.
Okay. For MOU, and if our both sides discussion and get agree, and if both sides is satisfied, then we can sign the MOU for the space educations.
Thank you.
I see that Dr. Ammar Sakaji wants to ask one more question. Please, Dr. Ammar, introduce yourself, please.
Thank you so much. Thank you, Dr. Wang, for this lecture. Let's go again to a ground station. My question is more technical. As we know, Starlink system or projects they launched a few weeks ago around 6 satellites in the low orbit, around 600 kilometers. And they are using non-geostationary satellites, and they increase the frequency to suit the low, and they increase the frequency to suit the non-geostationary satellites. So the question is, and also their dish is around 48 centimeters. You mentioned your lecture that you have a ground station in San Francisco or Washington with around 5 meters dishes. How about the size of the dishes compared to Starlink or SpaceX technology? Is the same, or that it is very specific dishes?
It's clear, Dr. Wang?
Yeah. Okay. For the SpaceX, the company, they already launched a lot of the, they established the Starlink, and most of the satellite is in LEO orbit. At present, if the satellite, our ground station network, we must focus on the UHF, VHF, S-band, and X-band. But in my understanding, the Starlink, their frequency is not UHF, VHF, S, and X-band. So at present, we do not, in our ground station network, at present, it is not capacity to track the Starlink satellite in orbit.
I see. No. Anybody want to ask a question?
Because our at present our ground station network, it is still more focused on the education and training work, and the data rate also at present also a little bit low. It is not more focused on the commercial satellite.
Thank you, Dr. Wang. Then, if I know more question, I would ask Dr. Auni to conclude this lecture, please.
Okay, thank you very much. At the end of this valuable and important presentation, I would like to thank Professor Wang for this effort which he has given us. And really, I got a chance to visit the ground station, which is hosted by Bihang University and the Regional Center of Asian Pacific. It was wonderful. And the question was actually directly with Mr. Wang, how we can establish, let me say, a ground station in Regional Center of Western Asia. And we have already discussed this thing, and he has actually suggested to us how we can start. Let's hope that we will be able to do it, at least for the regional center in Jordan, and it will help and for all the regions. Again, this is actually a question, the same, which is my deputy, Dr. Ala Al-Nahri, which we are always proud of his suggestion and recommendation. He has just took this chance to ask the direct question, which we have already discussed before. Anyhow, I have seen many actually of my colleagues who is now attending, like Dr. Jihad Hijazi, You are welcome, Dr. Jihad. It's really our pleasure to see you. You are participating in this lectures.
Thank you for inviting me.
Dr. Jihad Hijazi, actually, he's the pioneer of remote sensing doctors in our region, not only in Jordan, and now he is actually working actively and based in Dubai. Many doctors like Dr. Shedani from Oman, you are welcome, Dr. Mukarram, Dr. Ashraf, and more also. There are a few maybe Chinese students. They are now also participating in this important lectures. It is an opportunity for us actually. So Dr. Wang, on behalf of my colleagues, I should not forget my dear friend, Dr. Osama Shalabiya, who is now also playing a very important role in advancing the space science technology in our region.
Thank you. Thank you.
You see, really, I am very much impressed of so many people. Dr. Ammar, you should I must apologize if I didn't mention names, but you see, because already I have seen their faces in the camera. So please, on behalf of all my let me say colleagues, who is really, we are proud of them. My Adamo from Nigeria, also you are welcome. So please, on behalf of all actually participants, let me take this chance to thank you and to convey my best regards and gratitude to your nice presentation and to your nice personality. And I would like to remind all participants now that tomorrow and after tomorrow, we will start a new course. It's a workshop for 2 days concerning under a title of GNSS application. So Dr. Xian, he will also actually give us this workshop, and he's insisting that must be recorded because his students also will attend. You know, nowadays, most of the teaching, it's online. So I tell you frankly that all of these presentation already we have recorded, and it will be actually broadcast on the channel which is specified for Arab Union for Astronomy and Space Science and the Regional Center for Space Science and Technology. Thank you very much, Dr. Wang, and thank you for everybody who is attending this actually virtual online presentation, and I wish you a nice day, and thank you and goodbye.
Many thanks, Dr. Aouni, for this invitation and also for bringing eminent people to share their experience and also to highlight the opportunities that's becoming now global, and also for the great development that we are doing in the regional center in Jordan for the sake of the whole region here. We really appreciate all this effort, and we thank you greatly for all these initiatives that you are bringing to the area, to the region, and really we are very proud of your achievement and the achievement also in China and their willingness to share and to build a global network for the better of mankind. Thank you very much again.
Thank you, Dr. Saleh Shedani from Oman. Thank you. So kind of you, Professor.
Many thanks, Professor.
Hassan Al-Sabbar. Assalamu alaikum. Ahlan wa sahlan. I wish you all the best and goodbye.
Bye-bye. Thank you. Bye-bye.
Bye-bye. Thank you.